All right, it's 11:30. Please welcome to the stage everybody, Rachel and Jamal, who are going to walk us through PII detection at scale on the Lakehouse. Take it away.
So, good morning, everyone. Suckers for punishment, huh? Keynote speech, and now you want to learn about PII. So personal information. How can AI change governance? I guess that's the big question that we're thinking about. I don't know where some of you are from. Put your hands up if you're from an industry that's regulated. Oh, no wonder you're here. Even industries that are not regulated today, you know, you have got a lot of privacy policies which are coming out and impacting us all. So I'm going through a second data transformation at the moment, and the first one I did a lot of processes and I observed a lot of waste in the organization. So I want to talk a little bit about what the problem is that we're trying to solve. So in a regulated industry, you have one more audit than a non-regulated industry. You have shareholders audits, you have regulatory audits, and then internally you have internal audits. And then if you're a governance team, you're preparing for an audit. So I think in 1 year I had 3 audits, and we're very internally busy. And after running through a bit of a program and seeing all of this and watching what happens, and then you watch that the god of your corporation can't sleep at night because all the metrics say that they're all worried about a cybersecurity breach, and they're also worried about data leakage. So I've noticed they don't really worry about it too much unless it's in the market that they're in, and they're observing other CEOs go downhill as they're trying to communicate the breach. So these things are impacting us, and the regulators are bringing in big fines. So that's kind of the situation that we're faced with. So after doing one program and thinking through this, and at the end of the program I thought, damn it, that's what I should have done at the start. But technology wasn't advanced, and today we're in a new era. So we're going to go through a little bit about one of these lessons that I learned and how technology can change the game. So today, I'll just introduce myself. I'm from Seek. Ajmal is from Databricks. He's helped us out. I'll go through a little bit about our company and the problem, and then Ajmal will talk a little bit about how we're trying to solve the solution. So Seek, okay, so for all of you, if you've applied for a job recently or someone has tried to poach you, depending on which country you come from, you might have gone through Indeed or LinkedIn. In Asia Pacific, the #1 job portal in the markets we operate is Seek. So Seek is an employment marketplace. We basically match candidates with hirers, and we have fairly sophisticated preferences about what people want to do, what hirers want. They engage actively, and we need trust. So Seek operates in 8 markets. We have 3 brands at the moment. In the next year and a half, we'll move to one brand called Seek.com. But currently, we've got JobsDB in Hong Kong and in Thailand. We've got JobStreet Philippines, Malaysia, Singapore, Indonesia, and we've got Seek in Australia and New Zealand. We're basically like a LinkedIn without that social aspect. We have quite a lot of data as per any marketplace. 2 metrics I'll give you is more than 40 million profiles we have on our store, and every year we've got over 500 million applications for jobs. So we're sending data, personal information data, to quite a significant number of endpoints. We use Databricks today mostly in our AI team. We're looking to see now whether we consolidate that across the whole company. We have 135 active daily users that use it, and we use it on our application and product, basically for nudges and experimentation and matching profiles. So it's quite actively used and a very important part of our ecosystem. The way that we use, or the process is probably fairly obvious to many of you. People come in, they upload their CV, but they also upload a lot of other personal information. So they upload a cover letter, and then some of them try to justify how much they're earning in their current jobs, so then they upload their tax statement. They might upload their credit card details, their driver's license, all kinds of things. I don't know if it's accidental or on purpose, but we get a lot of sensitive information, and we just store it. So the process is basically this upload, then we go through a few steps which massages the data into a model, and we provide candidate recommendations. And then we do this across multiple parts of our product, so PII data is quite prolific. In Australia, where we're headquartered, in the last year we've had 5 major cybersecurity breaches. So what happens after this is normally, and which is taking place by December, the regulator will bring in PDPA-style regulations. So Europe's ahead of us, but also in Philippines and Thailand, our other 2 markets, PDPA is in place. So we expect the rest of Asia to follow. But I think after all these cybersecurity events, the question becomes also, how do we communicate? Do we really know where our data is? Can we communicate how many profiles have been hit? Can we get back to the customers the minute it happens? Can we tell them what data has been breached? And can we provide them the right advice? So the reputational loss of a cyber breach now is the communications you do thereafter. And what is the cost of privacy? So if you have to replace someone's privacy, their passport, their driver's license, you can actually put a number to it. So we now have a position to actually quantify risk. And I can now say to the CEO, this is how much risk we've got. We're over-collecting or over-retaining a certain amount of data. This is what we need to do. This is how we're going to burn it down. And we're going to use AI to solve that problem. So we talked a bit about the cyber threats, the privacy requirements. So in terms of design principles about what we want to do, we're a data team, so we should drink our own champagne. We should be data-driven ourselves. We preach it to others. So how does data governance, which is traditionally not a data team, they govern it, they kind of do sample checks. How do you convert that into a team which is really AI, data scientists, data engineers, and thinking about driving governance with data? So that's the mindset shift. If you've got 5 people to do governance, do you want engineers and AI people, or do you want people that can go and sample check and do the manual process? Probably you need a bit of both, but we want to kind of push a bit more towards the data-driven end. Audit by design, try to get it up front and early, design for no operations, complete automation. And we want to, in this use case, we're talking about making sure we've got the confidence we don't over-collect data or over-retain data. So that's what we're trying to solve. So the vision here is really to think about data surveillance as not as an afterthought, but think about data surveillance of our environment upfront and early. If you can create a surveillance function by scanning your data, understanding what you've got, whether you're over-collecting, over-retaining, who's accessing it, all these things, you start to create a pattern, and when patterns shift and change, you've got more control. And the more near-time or real-time the information is, the more in control you are, the more you can sleep at night, the more the CEO likes you. You're reducing risk, or you know your risk. So the vision here is really, can we build a system now that exposes those gaps, delivers a dashboard pretty much in near time, triggers tickets to the custodians of the data to act on these issues. Okay, so I pass the challenge across to Ajmal, and he'll talk to you about what we're doing in a pilot.
Okay, can everyone hear me? Yes, awesome. Thanks, Rachel. So I'm going to talk you through something that I'm really excited about that Seek's engineers and I have been building for the past few months, which is a proper end-to-end PII detection module that starts with the specific context that Seek has with respect to its data, wherever it may reside. So if I direct your attention to the left-hand side of this diagram, we start to look at exactly where data may reside within either their structured, semi-structured, or unstructured domains for where data may actualize. If you look at CVs, they're heavily unstructured, right? They come in PDFs, they come in docx. You want to be able to scan all that text, and where Seek has this data is primarily within their cloud object storage. They also have data that their AI team leverages to be able to build their exciting ML products that make their product more efficient and faster, and that typically resides within their Unity Catalog metastore in the format of tables that are all connected together with columns and specific types across each one of them. What our PII detection module does is it actually scans both of these different data domains for PII. It has 4 key elements, and I'm going to talk you through each one of these elements, but at the output of all this actually delivers to the vision that Rachel mentioned earlier, an actual dashboard that users can use to look at what their overall risk exposure is in terms of their PII, wherever it may reside. It also triggers alerts to Jira if needed, so that data custodians can then see, hey, we're over-retaining this specific data set, we probably shouldn't do that. And thanks to Unity Catalog, we also can track lineage, so that if we do find PII within their databases and catalogs, we can create new tables based on that and then leverage the power of Unity Catalog to look at where the new tables are from the PII detected tables. And you still maintain that lineage, which is relatively important if you're building machine learning models. And then lastly, leveraging Unity Catalog, we're actually able to enforce access controls based on the detected PII. So what you have here essentially is a proper end-to-end inputs all the way to actionable outputs, detection, identification of PII, tailored to Seek's specific domain that they operate in. So I'll talk you through each one of these elements now. Okay, so firstly, we're going to start with this idea of leveraging this library called Presidio, so the 2 little boxes within the pandas UDF that I've mentioned here, and I'll deep dive into those. And before I go into that, I'll just mention really quickly that this entire module essentially is a series of pandas UDFs that are optimized to be applied within either S3 or catalogs and databases, and we're actually going to be open sourcing this as well, so people can leverage this end-to-end on their Databricks deployment as well. So if we look at the actual detection element of it, as well as the obfuscation element, we essentially leverage this library called Presidio. The whole thing actually is built on open source, and we're going to be open sourcing it as well. And if you look at Presidio, there's really 2 key elements to it. There's an identification of PII, and then a subsequent obfuscation of PII as well. And we found that this library was really interesting because we could actually tailor this to Seek's use case, and it was quite customizable as well. So I'll start off on the left-hand side, which is around the recognition of PII. So essentially, Presidio has this idea of a recognizer registry. And you can put your own recognizers into that as well to find PII. And essentially, it's got some pre-built elements that leverage regex, as well as this idea of context words. So if you have a text that says, hi, my name is Rachel, and my number is X, Y, and Z, we can identify based on named entity recognition, or NER, that there is a name here. We can leverage Presidio's contextual elements to be able to say that if the word name is mentioned, then there's probably a likelihood that you might see an actual name after the name is mentioned. If you see that number is mentioned, there's again another likelihood that you might see that number is mentioned. You can customize these and actually provide scores to say how confident you are that PII exists. So we built a custom NER that is built using HuggingFace. And because Seek operates in very many domains across the APAC region, you want to be able to be essentially robust to very different types of names that might emerge in Asia or Australia. So using HuggingFace actually ended up giving us relatively good results for that. Another bit that's actually mentioned as part of this talk's abstract is that the phrase CEO of Databricks is actually PII, because I know that Ali Goodsey is the CEO of Databricks. But the term software engineer at Databricks, which you might find in your CV, is not PII at all, right? Because there's quite a few software engineers that we have at Databricks. And so we actually leverage this context words to be able to customize it within the job domain as well. So that was quite an interesting add-on. Now, once you've identified PII, Presidio actually tells you the probability that there is PII here. It also tells you exactly where PII was detected as well, within the actual text that was fed in. So it also has essentially pre-built anonymizers as well. So again, identification and then anonymization. Within anonymization, you actually have many different techniques that you can use. So you can use hashing, you can use redaction, so you can just get rid of PII altogether. But within Seek's context, it's actually quite interesting to use replacement. So I want to essentially find where my PII is, and then in text replace what type of PII I've identified. Now, this is specifically important for building machine learning use cases, because you still maintain that contextual signal that is useful for building machine learning models off CVs and things like that. So we leverage the in-text replacement for that. So that's PII extended to Seek's context, as well as leveraging HuggingFace. We also had a few other recognizers that we created and built specifically for the Australian domain, because we look at like tax file numbers as being PII, because there's a one-to-one mapping between citizens of Australian tax file numbers, as well as driver's licenses as well, which weren't within the open source library. Awesome. Now, another bit that we extended as well is that, as Rachel mentioned, people put some very strong PII within their CVs, typically when they don't necessarily have to, so this is a little bit of like saving people from themselves. So if somebody puts in their passport into their CV, and we have seen some instances of this, we're actually able to leverage OCR. So we can actually do optical character recognition to pull in the passport details and then pass it to our PII module to then identify that, hey, there's a passport number that's been identified within the CV. And this typically emerges when data is sitting in S3. So I'm so sorry, I thought the screens would be bigger, but I promise you, if you were to zoom in, you would see that we read in a CV that had a passport number, and our module identified that, hey, there is an Australian passport starting here, ending here, and there's this probability of like identifying it. So that's actually really interesting, and it saves us also from driver's licenses because we extended it to the Australian context, as well as when people upload their tax file statements, which they shouldn't, but if they do, we can find it. So it's there as well. Moving on. Now, another really interesting bit that Rachel mentioned is she wanted essentially auditability up front, right? So using MLflow, we can actually we have wrapped the actual PII detection module as an MLflow model. Now, yes, this allows us to leverage the model registry. It allows us to do lifecycle tracking of the actual model as well as like governance of the model. But more importantly, we're actually able to leverage this within model serving. So we can create an API that essentially tells you, hey, I found the tax file number, start, end, probability, as well as the recognizer that I used within my registry, as well as anonymize it as well. And this is particularly useful because Seek has form filling for when they actually, like users come in and fill out their CVs, sorry, their skills. So if somebody comes in, uploads their CV, we can trigger this API, hey, you've given us your tax file number, please don't do that. And then more interestingly, if they're in their actual like form fill fields and they're putting in their passport number, which they shouldn't, but if they do, we can identify it really quickly and raise an alert to the user that says, please don't give us this information. So you almost like stop it at the beginning, as well as do like a retrospective with the module as well on what you have currently today. So this is more of like that future-looking piece. And again, all of the PII detection modules and anonymization modules can all be wrapped up within MLflow, which has a lot of added benefits there as well. And you can also apply it as UDFs too, thanks to that. So moving on, when you have a lot of data like Seek does, you probably want to do this in a relatively cost-efficient way, because scanning for PII historically requires you to essentially go in, open up every single file, read the contents of that file to ensure that there's no PII either at the start or the end of that. And yes, when you have like databases and tables, you can absolutely sample because you expect some level of like homogeneity within like the actual columns themselves. But when you have data sitting on S3, like in a PDF format, you want to open all of that. And so we looked at a little bit of comparison against what we, against like a linear system. So a couple of systems that we identified charge you based on like the amount of data scanned, and that's it. And it's a linear like correlation between the amount of data that you have and the cost that you incur as a result of that scan. Now, because we're leveraging Databricks and Spark, we start to see some really interesting scaling properties as a consequence of that. And that's exactly what you'd expect when you're actually distributing your computation across a cluster. So the time to execution was not linear at all, so going from 1 gigabyte to 10 gigabytes. When we look at the costing, we started to see some interesting scaling properties with respect to the costing as well, so it wasn't a linear relationship, which is interesting. And we've also included like some comparisons there. So we're actually working on a blog post at the moment that shows all of the results that you see here, against a bunch of benchmarking. I'll tease that very quickly, but we won't go into the details. But we found that there are some interesting arrow-like records per batch configs that you can change to be able to start to see some performance improvements. And we'll have a proper blog post that details that out in significantly more detail. So moving on, now you've scanned your PII, you've used these modules to actually identify where it is. What do you do now? So if the data is sitting within your databases and tables, this is where Unity Catalog starts to really shine. So if we look at the left-hand side, we actually create an audit table that users can leverage to say that, hey, within this catalog, within this database, and this table, you have PII. And you can leverage that to then change your access control lists as a consequence of that. What you can also do is you can apply table properties, which we have done, as key value pairs that tell you that this table has this PII in this column. Now, UC obviously has a roadmap that lets you change access controls based on tags, but this is just us leveraging what we could today to be able to create just table properties. So you have some level of like contextual metadata that you can leverage that says this table has PII, it is within this column, and that's it. So, and when you do that and you create new tables, as I've mentioned here, you can leverage UC again to then be able to say that, hey, I created a new table because this old table had PII. I've leveraged the anonymization or obfuscation techniques within this module. This new table is completely obfuscated, but you still maintain lineage all the way down to the column level so that you can still maintain some level of traceability that says that like this table had PII. And you would absolutely go in and change the actual owner of this table or who can access this table based on UC's access control lists. So again, if you could zoom in, I promise, if you had like monocles, you could see that this table has owner admin and this table has analysts. So the analyst wouldn't even know that there's like a PII table, for example. That's really useful as well. And then lastly, as Rachel mentioned, I'll just quickly go through our dashboard. But the dashboard essentially can tell you, hey, these are the paths in S3 that we've identified that have PII. What is the type of PII? What is your overall risk exposure? Because you still have to handle PII, but you want to have some level of visibility over it. Where was it identified? And what is your essentially retention period for this? And once your retention period is exceeded, based on the time that you've kept that data, you can then identify gaps. And if you start to see that those gaps have gone above a threshold that would be acceptable for the organization, you can trigger alerts against webhooks, and now you've got a proper end-to-end identification, obfuscation, and actionable insights that you can use with your analyst teams to go in and say, hey, this data set probably shouldn't be here. So that's what this dashboard shows. Again, when we release the GitHub repo, you'll all be able to actually play with this yourselves with your data sets. And that's it.
Ajmal, I just would say one more thing is that after we're doing the scan and we understand actually what the size of the problem is, then starts the next phase. How do you solve it? So if you don't know the size of the problem, you just have one way to solve the problem. When you actually see what the quantity is, then you start to make business decisions about, do you want to re-engage with the customer? Because they actually own the data. It's not ours. So do they want to fix it, or do we want to fix it, or how do we fix that? And then how do we manage that across the tentacles that we send it to? So having a thought process about seeing what is reality up front means that you start thinking about how you might want to solve the problem, and you may not solve it in the traditional manner. And that could save you a lot of time and a lot of money. And it could also be a very positive situation to go back to your customers to indicate to them that you're professionally managing their data. But without scanning, you don't have that information up front. You can't make those business decisions. You don't know how much risk you've got. So I think it kind of does the full cycle, and it also gives people an appreciation for what's happening at the front end and how the product is performing. So.